Are you recording?
Yeah, I'm recording. I'm trying to start up my whiteboard app right now, but then it's not working.
You can use Google Jamboard.
Wait, it worked now. Okay. My computer is lagging a lot right now. I'm not sure why. Okay, y'all can see the whiteboard, right? Okay, so uh okay, so first is buckets. So what buckets is basically, right, most of the time you have, like, for example, an array of size n. Then what you want to do is that you want to split them up into, like, buckets of size b, where b is normally square root. Sometimes b can be other stuff, but then normally b is square root n. Like, sometimes it can be like square root n log n or something. And, like, there are some rare case, like for example in, like, the 4 Russian streak, b is like log 2 n over 2. But we won't cover that for now. Yeah, so like, the idea behind this is that after you split it up into blocks, right, like if, like, the block size is like square root n, like, the idea is that, like, whenever we have updates or something, right, like, let's say we have an update to some element here, we can just rebuild the entire bucket. So we can like do, like, trivial brute force, right, on that single bucket to recalculate, like, all the information that we want to maintain. And then after that, if you have, like, for example, a query, right, if you have a query, what you can do is that you make use of the pre-computed things inside a bucket to be able to, like, consider the whole bucket together. So for example, if you have this kind of query, right, you can use this pre-computed bucket information to calculate, like, the contribution to the answer to for, like, a certain bucket. Yeah, so you can do this, right, then there for each query you only visit n over b buckets, and then at the same time for, like, the sites, right, for the site, since it's not fully contained inside the bucket, we can just iterate through each element one by one. So this will take plus 2b, because on both sides you need to iterate through each element one by one. Yeah, so like, if the equation is something like that, most of the time when b is square root n, right, that's the most optimal one. So no, are there any questions for now? Okay, if not, we can move on to the example problems. So we will take a look at the first problem first. Uh, the first problem is host. Hopefully you all have read the problem already. Basically what the problem is that each hole has a power, then whenever you throw a ball into I, you jump to I plus AI. Then after that, it will keep happening until it jumps out of the row which is exceeds n. Yeah, and then there are also updates. Then after that, you want to find the number of the last host visited plus the number of jumps. Okay, so in this problem, it is uh, so what you want to do in this problem is buckets also. So we have blocks of size b, right? So most of the time in like problems that involve buckets, right? Like your thought process should be inside. Wait, I didn't share my whiteboard. Okay, so most of the time in buckets question, right? What the first thing that you should think of is what information do we need to keep inside the bucket? So what you should think about is that if we have a query, how can we handle a single bucket like at once? So for example in this question host, right? Like since it involves like jumping around, right? So like if we want to handle like a single bucket, let's say we have this bucket B, then if like for example the ball like enters somewhere here and then it jumps here, like there might be a lot of small jumps inside here. But if we have a lot of small jumps, right, then our time complexity will be very bad because we have to go through each jump one by one. So in order to like handle the bucket all at once, right, like we want to do a single bucket in like one time. What we can do is that for each bucket we store, if we start at a certain point, what is the number of jumps it takes for it to exit the bucket, and at the same time last what is the last position it was at before it jumped out of the bucket. So this information is actually quite similar to what the question is asking. Like the question is asking like what is the last hole it jumped out from and also the number of jumps. So for in this case, instead of like the final answer, we store what is the last hole it visited before it exited its own bucket, and also what's the number of jumps it takes for it to exit its own bucket. So in order to pre-compute this, we can just do the naive brute force, which is we go from for each bucket we go from right to left, and we do something like dynamic programming. So the last most one in the bucket, obviously like it doesn't need any jump to like you just need one jump for it to exit the bucket already, and then uh like the last thing it visited before exiting a bucket is itself. Then like in the like when you go down, right, then if you have like edge pointing towards the right, then you just update the like something like a dynamic programming transition, which is like this one is just the number of jumps equals to like this jumps plus one, then after that the last one is equals to the last for this one. Yeah, then you just keep doing like this kind of dynamic programming, so we can compute this information in OB time. So since like we can compute this in OB time, right, this also means that if we have an update, like if for example if we have an update to this position here, right, then instead of this edge we have like a big edge like that or something. So in this case it's also the same. We can just forget that we had all this information, and we just rebuild the entire thing. We rebuild in this OB time. So then after that for the query, right, it's just if we start at a certain position, let's say we have the buckets, and let's say we start at this hole. So it's the same thing. We can use the pre-computed array to find what's the first time that it jumps out. So in a single O1 time, we can go to this age already. Then after that, we also know what's the number of jumps and what's the last one. Then after that, after we get this one, we also use the same pre-computed array to find what's the first time that it exits. So this is also O1 time. So if you keep repeating this, this will be O n over b time. So since this is like O n over b plus b, then the optimal b is equal to square root n. Yeah, so that is solved. Does anyone have any questions? Yes, it is recorded. Okay, the next question is Dominoes. This question is actually set by me. So yeah, so it's actually quite a similar scenario as like the previous problem, where it's sort of jumping, but instead of jumping, it's like the dominoes topple on each other. So when one thing topple, then like everything that the domino hit on the way that it topples will also get toppled. So we will have queries where we change the height of the domino, and also we want to print the furthest domino that's toppled after toppling a single domino. Yeah, so for this problem, so we have buckets. So like I said earlier, right, the first thing you should think of is what do you need to store inside the bucket so that you can handle all the operations all at once. So for this problem, what we want to store is the furthest what we want to store is like sort of if a single domino topple down, then if there's like dollar domino in the way, like you want to sort of know like what is the furthest range that you can reach using only the dominoes from a single bucket. So let me try to illustrate what I'm saying. So for example, you have this thing that goes very far. So let's say this is a single bucket. Yeah, so what you want to store is that like inside like this single bucket alone, right? What is the furthest, like if you keep toppling the domino, what is the furthest like x plus h that exists among all the dominoes that topple within the bucket itself? Like the reason we want to store this is because we we want to know like we want to keep toppling the dominoes, because when a domino topples, then it will cause like a chain reaction, and like in order to know what how it will affect the next bucket, we need to know the furthest one, because like for example, like the stuff here is not useful because like this is the furthest, right? So whatever this topples, the longest one will always topple also. So you want to find like the maximum x plus h among all the stuff, all the dominoes that it topples. Then if we have this information, right, then we can also, when we move on to the next bucket, we can make use of the pre-computed information to find out, like, in this range, what's the max x plus h that it can reach if you topple the stuff here. Yeah, then in this case, maybe this is the maximum x plus h. Okay, and then so we need to think about how we can store this information. And also another minor detail is that uh, like, we want to store the max plus h if we topple a single domino inside the bucket, right? But at the same time, this is not sufficient, because if you look at this case, right, like, we want to find the max x plus h if we topple a prefix of the bucket, because if we have a very long thing that topples to the next bucket, the entire prefix need to be toppled down, and we cannot just, like, choose an arbitrary domino to topple down inside this prefix, because we can have a case like, for example, we have let's say, if we assume we just topple this one, but then maybe, like, something before that is, like, a longer range, so you actually need to consider, like, the entire prefix. If you topple the entire prefix, what's the maximum x plus h among all the domino that topples inside this bucket itself. So now we need to think how we can calculate the max x plus h among all domino that topples within the bucket if domino I is toppled. And then we also need to consider if a prefix from, like, let's say, start to I, where start is the start of the bucket. Does anyone have any questions so far? Okay, if there are no questions, then we can continue. So we need to find out how to calculate these two information. So this is also something like DP, because if we go from right to left again, this B, then let's say we have something like, so this one, we know that if this one topples, the only thing that it will topple is up to here, so this one, the maximum x plus h is just itself. And then if this one topples, like, this whole thing topples. So for this one, I think did I use a stack? Wait, let me check. If you have any questions, just ask, by the way. Everyone can learn from your question. Yeah, something like a stack. Okay, so in order to calculate this, right, it's like uh your stack stores is like a monotonic stack where in the stack you want to store in decreasing x plus h. So the idea behind this is that as you go from right to left, right, obviously the bigger x plus h is the most important one because we want to store what's the maximum x plus h that you can reach. So they can look something like that. It can be slightly taller also as long as the x plus h is decreasing. But at the same time, when you have a new domino, like even though you want to take this one, but if you topple down, like maybe you cannot reach this one. So if you cannot reach the domino, then you have to pop away from the stack until you only can reach this one. So actually this is not x plus h, this is more like dp value of I, where the dp value of I is what's the maximum x plus h if the ith domino is toppled. Yeah, so uh maybe the code is actually never mind. Yeah, so the idea is that if you when you go from right to left, you store like a decreasing stack of the x plus h. Yeah. Okay, and then for the for this case where it's the prefix, like what we need to do is just take the prefix maximum and we take the dp value of all the prefix. And for this one, we just take the maximum of everything here. And after that, we can get the answer. Other questions? Yeah, then for the query is what I mentioned just now. It's just when you jump. Oh yeah, and when you jump, since we only store the maximum x plus h, right? So like in the next bucket, we don't actually know like which index in the bucket we need to consider the dp value of. So what we can do is that we can do a lower bound inside the bucket lah. Like this will incur like an additional log, but actually like the constant is so small that it actually also passes. But if you want to try, there's actually also a way to do in pure square root. So it's something like n square root n plus like q log or something. Yeah, something like that. But that's not needed for this problem. Are there any questions? Actually, in my code, I did something different. Okay, so this is my code. So the x is the position of the domino and h is the height of domino. Then the EISI is the end point and start point of the bucket. And this is actually the pure square solution. So we have this funny base thingy. but that's not important, I think. So yeah, like my stack actually stores like the dominoes that have not been toppled by the previous things yet. So we check whether we can topple it, and then if we can topple it, then we extend the range. R is like the furthest that we can reach, like the maximum x plus j so far. So if like inside the stack we can find a position that is smaller than equals to the maximum range, then we just keep extending. Yeah, then this one is just we take the prefix maximum, something like that. I'll let you all process it for a while. Then if you all have any questions, you all can type in the chat. Okay, since there are no questions, I'll continue. Okay, this one is a bit tricky because it's not the same as the previous questions that we have had. So for this one it's like it looks like a segment tree question. So we have an array, then we have a function which is the function is just it returns the range sum. And it returns the sum of all aj between L and R. And this L and R is the property of the function. Then we can update the array, and we can also ask to print the sum of all the functions from L to R. Yeah, so can look at the example like from 1 to 4, which means that we want these 4 functions. So this means that f1 is 1 plus 2 plus 3, f2 is 2 plus 3 plus 4 plus 5, and like what you see here. So for the query 1, we want 1 to 4. So you f1 plus f2 plus f3 plus f4 equals 21. Okay, so for this question, right, instead of like what we did previously where we bucket the array, right, this time the bucketing the array doesn't really help. So for this one, what we want to do instead is we bucket the functions. So we have an array. This is array A. Then we have the functions. So we will represent the functions as like a square also. So this function L to R means that this is equals to the sum. So we have like this function, and let's say we have this function and this function. Yeah, so uh what we want to do like with the functions is that we want to bucket them up. So let's say we have b functions here, then we have another bunch of random functions, and this is another block. So the reason why we want to bucket the function is because of query number 2. So the query number 2, we want to print the sum of all functions from L to R, right? So if we can bucket the functions, we can use like what we did similarly in the previous problems, where actually also not similar to our previous problem. Similar to what I said at the start, which is like we can, if like we have a query like that, then we can consider like this part individually, then the bucket all by itself, and then the remaining part individually. So now we need to figure out how we can, like if we bucket the function, right, like what I said earlier, the first thing you need to think of is what do we need to store inside the bucket. So now we need to think about, like, if we bucket up the functions, how can we, like, what information do we need to store so that we can find the sum of all the functions in O1 time, like within the same bucket. So like the most obvious thing is obviously we store the sum lah. So like we just store the sum of all the functions inside the bucket. So like if we can maintain this sum, right, then it is very easy for us to uh do the query, because like we can, like for the loan one, right, we can I'm not sure whether it's fast enough, but we if it's fast enough, we can just use a fabric tree, right, to find the query for each function. So there will be an additional log factor, but the constant time is also very small because fabric tree is very fast. Yeah, then for the bucket, right, we just use the pre-computed sum. So now the only hard part is how can we maintain the sum after the updates? Because uh the update is change an element of the array, right? Like if you change an element of the array, like this update is very hard because it affects all buckets at once. So like if like we rebuild all the everything, right? Like if we rebuild this bucket, then we also rebuild the bottom bucket, then if we need to rebuild everything, then it will be on time after each update, which is very bad. So like now we need to think like another layer. So if we want to maintain the sum, if we want to maintain the sum, is there other information that we can maintain so that we can update this sum easily? And actually there is a way. So for each bucket, what we can do is that we calculate how many functions require like a value. So for L to R, right, this means that this function requires everything in the range of this. So what this means is that if anything receives an update here, right, there will be one function inside this bucket that will be affected by the update. So in the same way, right, we do the same thing for all the functions in the bucket. So it's sort of like a range increment. So in this range, right, we say that there's one thing that requires there's one function that uses that element. Then here we need to do another +1. Here we need to do another +1. And then here another +1. So what this means is that, like for example, if we have this update, right, like you can see that here there are 3 functions that are inside that will be affected by the update. So this means that, like for example, if the initial value is x and then you change to y, this means that the change in sum, right, sum will be equals to sum minus x times 3x, because there are 3 functions that will be affected by the update. Then after that, the new value is 3y. So if we maintain this, right, this means that for each bucket we can update in O1 time, because all we need to do is that we need to just find this pre-computed contribution. So if we can update all the buckets in O1 time, this is OB time for each update. And then if you look at, like, it might look like the memory is very bad, because like we need to store like the entire, we need to store ON memory for each bucket. But actually it's not that bad, because it's just for each bucket we store N, right, memory. And then B, if we let B equal square root N, so this is just N square root N memory. And I think that is okay for this problem. And the question didn't even say the memory limit, so I think it should be fine. So does anyone have any question?
What will happen to the values? Like, we can update the sum of the total sum in each bucket, but what about the individual? Like when query 2 of L2R, some of them will fall outside bucket, right? And we have to compute them separately.
You are saying like the parts where the separate one, right?
Hey, what I'm saying is, like, when the second query is asked, the L2R, some of them will be in buckets and some of them will be outside the bucket, right? Like only few elements of the bucket.
Yeah, so
What
the
about
things that are outside the bucket, like for example, if we have a query like that, right, L to R, then you are saying that like the buckets can be something like that, right?
yes.
Then like this stuff will be outside the bucket. Is that what you're saying?
Yes, yes.
Okay, so for this stuff, right, since there are only at most two B elements that are outside the bucket, so we can just, like, for each function we can just do a Fenwick tree, or yeah, binary index tree. I don't know what you all call it. Yeah, so it's like you just do like the normal type of brute force, which is like after each update you update to the Fenwick to the binary index tree, and then after that for each function you just do a range query, range query. Yeah, so this will be B log n. So there'll be like there will be a log inside lah, but I think it should be okay. I'm not sure whether we can remove the log. Does that answer your question?
Yes, yes.
Does anyone else have any question?
How would you, can you repeat the part when you said, if in some bucket the element that we have changed affects it?
Sorry, can you say that again?
Like when you change one element, how can you see which buckets will be affected? Can you
Okay, so
repeat that part?
when element is changed, right, actually we need to update all buckets, because it's possible that all buckets are updated. So the only way that we can speed up is that, because like for each bucket all we need to store is a single number, which is the sum. So it's theoretically possible to do each update in O1 time, because we only need to update a single integer. And the way that we can update each bucket in O1 time is that for each bucket we store like sort of an occurrence array, which is how many times a position how many times how do I say this, like for example like this, like if there's an update here, right, we want to count how many times the function contains that position. So in this case, like there are 3 functions that are affected by the update, and then if we have another update here, right, there are 2 functions that are affected by the update. So like we can update in O1 time using this formula, where this 3 is like the number of times like L smaller than what's the X. Okay, maybe X is not a good thing since it's used in the question. Let's just call it O and U. Okay, then okay, this is quite messy. Let me write at the bottom. So what we want to do is that for each bucket, right, we store an array. We store like OCC P. P is like the position, where equals to the number of functions in the bucket where L smaller than equals to P smaller than equals to R. So what this means is that for each position, you want to count how many functions are affected by the update. So if you can do this, right, then for each update, which is change the X element to a new value, right, like from old to new. So the sum will be equal to sum minus the occurrence of X multiplied by O plus occurrence X new. So this is because like there are this number of elements that are affected by the update. So we first need to remove the contribution of like the element of the array before the update, and then we add back the new contribution. Does this formula make sense?
Yeah.
What do you say, Blagoy?
Yeah.
Okay, so you get it now? Of course, you can do this in
Yeah,
O1.
I do. Thank you.
Yeah, then this occurrence array is n, it has n elements, so is, and then you need to store this array for each bucket.
बोला कि हाईएस्ट पॉसिबल होना चाहिए but people तो 3 consecutive money nights I guess ये मेरा हो गया था तो क्या था भाई मैंने क्या किया कि कैरेक्टर वाले लोग किसका चलेंगे साथ सारे चीजें और मैंने वन मान के चला मगर आई पे 1 मिला 10++ हुआ और जैसे ही 3 हो जाएगा तो सबसे छोटा वाला चीज मतलब
Are you asking a question?
लाइट चल रहा है क्या पता नहीं क्या पढ़ा रहा है ये शायद वो पढ़ा रहा है अभी ये एडवांस टॉपिक है ये पढ़ने पे मतलब
Okay. Yeah, so we need to store n elements for each bucket. So we need to store like O and B elements, which is like O n square n. Yeah, and then this array we can just pre-compute at the start because like the occurrence array doesn't actually change throughout the updates because the updates is only on the array itself. But for the functions, they won't get affected because like the L and R remains the same throughout all the updates. Yeah. Any other questions? Okay, if there are no questions, then we can move on to the next section, which is small versus big.